as I promised, gentlemen, we're going to look at the drawing now of the bolt and nut, but specifically the nut, because the nut is the only thing that is missing from our sectional assembly drawing that we're working on currently for the lever bracket. So now, the drawing of all the information that I needed was in the book, but I guess I have the teacher, so I have to guide you. So the topic that we are at now is engineering fasteners, and we had looked at some of it, but I'll create a more detailed video maybe tomorrow and show you what engineering fasteners are in details. However, in your book on page 57, it shows you how to construct a nut, right? And also it shows you all the different types, how to construct a bolt and how to draw it, right? However, we'll be focusing on nut for now. So here it says the procedures for drawing a hexagonal nut, right? And these are the procedures here, and it shows here for manual drawing. However, we are going to use AutoCAD, and this will make our lives much easier. But for now, what we will do is read the procedures and try to understand what it is saying. So it says here, procedure for drawing a hexagonal nut. And hex means you have 6 sides. All the measurements are based on the diameter, D, of the thread. And remember, the diameter of the thread is given by the M9, M18, M16, M14 metric diameter. So every measurement is based on your metric diameter, right? So stage 1, the plan is drawn first using a diameter of 1.5D. So simply mean you times the diameter, whatever it is, by 1.5. Draw the circle for the chamfer and construct a rectangular hexagon around it. So you say basically you draw a circle 1.5 times the diameter that you're given for the nut or for the bolt or the nut. Then you create a circle, and then you create the hexagon around the circle, right? And you know this is a distance across the flats. And diameter is this, which is the major diameter D, and then the inside one here would be a minor diameter, right? So remember, we talked about recently. We're going to discuss it in further details, but the internal circle is the internal diameter, the external circle is the external diameter, and this is the 1.5 times D for the head of the bolt. Alright, now the head of the bolt is basically the same exact thing as the nut, right? The same exact thing as the nut. So if you draw the head of a bolt, then you basically get a nut, because the bolt will fit perfectly inside the nut, right? So the head of a bolt is basically the same thing as the nut. So when you draw a nut, you basically can just attach from here downwards for the body of the bolt to get a bolt. So a nut plus a shaft creates a bolt. Alright, you will understand that further. So from the plan, project the corner of the hexagon into the front elevation. So from the plan, project the corner of the hexagon into the front elevation. So you put from the plan, you project to this and get the front elevation. Shows the thickness into the front elevation. Show the thickness of the nut as 0.8D. So whatever the diameter is, if it is M15 or M16, it is 0.8 times 15 or 0.8 times 16. You understand? So the thickness of the bolt or the height of the bolt is 0.8 times D. So 1.5 for the diameter of the head or the top of the bolt, and 0.8 for the thickness or the height. And draw the chamfer curve as shown. R is half the distance across the flats of the hexagon. So half the distance across the flats would be half of this from here to here. So basically the radius. So from the point to the point to draw them curve here. And when I get them curve here, draw this and this. However, for AutoCAD, we don't have to go through all this procedure because we're not drawing manually. So for AutoCAD, we'll just approximate it. and you will see it will not be hard. Alright, R is half the distance across the flats, right, as I said before. So half the distance across flat. On the end elevation, draw the chamfer curves as shown. So this is the front and this is the end. So plan front end for the nut. Stage 2, draw the chamfer curves on the second face on the bolt head only. One face is chamfered. So when you're doing a nut, right, you chamfer both faces, meaning you chop off the edges and make it look like that. You chamfer both faces, but on the bolt head, you only chamfer the top, because here so would be the flat piece and the bolt come down like that. And the bolt come down like that. So the bolt head and the nut are usually the same, except for the nut is chamfered on both ends, while the bolt head is just chamfered at the top. Alright. So see, bolt head, chamfer at the top, flat. That's how I go rest on the material. And then here so you have a washer, and then the nut is chamfered there and chamfered there. Alright. Next step, draw 30 degrees chamfer tangential to the curves in the front elevation and thickness the outlines. So it says draw 30 degrees chamfer, right, tangential to the curve at the front elevation and thicken the outlines. So right here, so this 30 degrees create a little chamfer right at the edge. So instead of carrying the flat piece going all the way out, if we get the box, they stop it right there and chop it off. Boom. Alright. So we're going to try doing this now. We'll cut this, use sniping tool here and just snipe it. See me? And then draw it. Then copy. This is a copy. So copy it and paste it in AutoCAD. So usually when you paste something in AutoCAD, that's what you do. Use a sniping tools, snip it. That's a snipping tool. You snip it, then copy it and paste it in AutoCAD, so you have your pictures or whatever. So when I give you drawings from your text, this is how you get it into AutoCAD. You just snip it from your book and you see, enter, and paste it in AutoCAD. Alright. So the question wanted us to draw let's see what size bolt. M18 bolt. So that's what we're going to start with. So an M18 bolt, not bolt, nut to put on the back of an M18 nut to put on the back of the pin. So now we'll draw the M18 nut. So the first thing that we'll do is, it says draw the plan first using the diameter. 1.5 times 18 is what? Let me use my calculator. 1.5 times 18 equal 27. So the circle that we're going to draw equal 27. Circle 27, enter, boom. Then we want a octagon on the outside of the circle, right? So you choose from the plan diameter the circle for the hexagon chamfer and construct a regular hexagon around it. So find the center point, center like that. Alright, so construct a regular hexagon around it. So polygon, 5 sides, 5, enter, and click, circumscribe. No, 5 sides, 6 sides, Jaja. Hexagon 6 sides, sorry. Polygon, enter the number on the side, 6, enter, and then circumscribe, because inscribe means go inside the circle, circumscribe means outside. Circumscribe it. That's it, we got the outside. So now that we have the outside of it, we want the inside, and the inside is 18. So draw the two 18 them. So 18, enter, and then what is inside diameter, which is about 1 millimeter. So do 17. So go circle again, and 17, enter. thread kind of look too narrow, so I'm gonna use 17, I use 16. So circle 16. Alright, that look a little better. Good. Notice the outside one can have a little break in it, we can trim that out later. But basically I done already. See that AutoCAD make life easy. Alright, so now we want the front. So we go project our lines down to arrive at the front. Then the front should be, according to the notes here, the front should be 0 point from the plan. Project the corners of the hexagon into the front elevation. Show the thickness of the nut as 0.8 times D. So D is 18, so 0.8 times D is, judge on that one calculator. So 0.8 times D, which is 18, equal 14.4. Alright. So just run it after 14. Let's run it after 14. Because I'm not name 14.4 in a virus division. 14. So run it after 14. So boom, offset 14. Enter. 10 bad though. Yeah man, bad. Run it after 15. So offset 15. Enter. Yep. Leave it at that. Then next step, you want to draw your line them down now. So trim them out. TR, enter. Trim. Some center line. Can adjust the type of lines that I use now. To center line. Change line type scale to 10. Double line that. Alright, so center line, come down. Now next thing I want to do, I get your curves. Now, according to the book, it has a note down here that says, note, the procedure for drawing the hexagonal nut and bolt is quite time consuming. Well, not from my experience. In practice, experienced draftsmen tend to estimate the curves and sizes once the plan hexagon has been drawn. So once you draw the plan, then just estimate the curve here. Because who go take time for you calculate and figure it out, so just estimate it. Alright. An alternative is to use a special template or dry transfer sheet of nuts and bolts that when I draw manually. But in AutoCAD, when I draw it, it's what I do. Just offset 2 millimeters, enter on both ends, and then use a curve, arch like that, bam, and then pull it up like that. Then adjust it as needed. Make it meet this up. And copy this and just paste it right through, you understand? Then boom, boomson, boomson, boomson. And then you can mirror this now. Mirror, find the center point, mirror it, enter. Then after mirror, you can move them down. M, enter, move it all the way down. Delete what the mirror. See that? And then you trim this now. TR, enter, trim. But 30 degrees of them stuff there, so I usually just left it, but let me just do the 30 degrees to not be a, you know, a hot skull. Paper skull. Alright, good. So 30 degrees. Yeah, that even look good. And even make sense. Let me see if I do a 30 degree chamfer, see? On the edge of that. But why am I do a 30 degree chamfer when Now I'm just trim it. No business. TR, enter. Like nobody go measure none. Yeah. And this way you draw a nut. And you only need two views. The end view, not necessary, but you can draw it for Pete's sake. Alright, let me see what I'm missing. So here's for trim motor, then piece here, so you trim again. TR, enter. TR, enter. So that tells me nut. Now if I want to draw a bolt, this is the same size, what I'm going to do is copy this, boom. Then instead of doing this down here, someone do this here, delete about that, delete about that, delete about that. Keep this flat, keep this flat. Understand? I'm going to extend EX, enter. Keep this flat. Trim it, TR, enter. Then just project down your internal and external diameter up here, so now go so Bamson. And the internal thread as a Bamson. Internal thread as a Bamson. So that. Then we go so. Cut that off this up. I'm kind of leave a look in the book now, see where how them draw the ends of the end of a bolt. Here, oh, them make a chamfer here, so and cut it off there, so alright, good. So it's easy to draw a nut, bolt and nut, you understand? Not difficult tonight. Easy peasy lemon squeeze, you understand? Easy breezy cover, girl. Alright, like that. And then this now go all the way up because the threading have to stop somewhere. So anywhere the threading stop, just pull an X bad boy upon it and chamfer it. So the chamfer come like this. That's so. That's so. That's so. That's so. Right. I'm look good. Just making sure. Okay, the chamfer goes like that. Good. From the threading outwards. So from the threading outwards. The same thing on this side. Transfer it across. Inside. And then we trim. TR, enter. Trim out that liner. Trim out liner. Trim out liner. Trim out liner. Trim out liner. Oh Carolina. Oh Carolina. Oh Carolina. 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 Oh Carolina. Oh, and have a cut grass there, so I'm doing the line incorrectly. Alright, so you have a cut grass there, so you see. What I mean. Alright, like that. So this represents the threading. This represents the bolt. Delete the extra line here. No, it can't stretch. Good. So this represents our M18 bolt and nut. So I can change the line type now and brighten it. So I'm going to select object line, MA match properties. Select all the lines that looks like it. I want to be bright. And that's you. That's you, my friend. That's you. Yeah, so, and you see they have this little creative like break in the two circles. Some of that just for creative essence, you know. Sometimes you know, be a G and you have to have a little creativity in there, you know. Understand? Creative essence. You understand? I'm that. Delete them extra line there. AutoCAD is the boss, you know. Alright, so now you done your screw now, you can just copy it because you don't need the plan, you just need to put it on the, let me see which drawings you need to put it on this one, side view, and the plan. So those two. So you copy them there, copy them note, copy from the center point, and move it to the back of the pin. Alright, so the M18 bolt connected to it Try look big though. But you're right, I guess. Yeah, man, you're right, man. It just look big. And then fling it on here, so too. So you rotate it, probably fling it on yourself, but rotate it a little bit. That's why AutoCAD is the bomb, because you can't rotate on paper. When you dry a nut one time, you have to dry it again to get a next one. You can't rotate nothing. So you have to dry it all 2-3 times. That's why Trinidad always beat you out in a CXC marks them, because them use AutoCAD from a longer time. And them they can done them paper faster than we. See that? So your M18 bolt upon it now. Measure it. Boy, it just look big though to me. No man, sit wrong, man. Something wrong. You know, nothing wrong. Nothing wrong, you know. The thing just how it's just how it look. Just how it look, man. M18 and check it car. Watch it. See you all there. 18, you see me? Measure the stud up as well. Most 18 we get to. See there? No, sir. I'm not 18 that. Yeah, I'm not 18 that. Draw it wrong. So, that's why it's too big. So, I draw it twice the measurement, but that's an easy fix. As I say, if you draw it on paper and you make them a mistake, you're dead. You go start over and you fail CXC. But, when I make that mistake in AutoCAD, you just take 5 minutes or 2 minutes and say, hey, I made a mistake, but okay. No problem. No problem. You delete the mistake. You say, no problem. It's all good. We don't have no worries here. No problem here. So, you can find out if this is 36, see me? I'm going to put this up here so somebody get it good. So, if this is 36 and I wanted it to be, it is 36 now. And 36 is what? And I want it to be 18. And 18 is half of 36. All I have to do is scale it. So, SC, enter, specify base point. It says scale factor or reference. So the scale factor you have to use to get this to 18 is 0.5. So I just scale it down by half. 0.5, enter. And it gets smaller by 5.5. So if I do the measurement now, it's 18. And the nut and bolt becomes the size I want it to be. You see, AutoCAD is, man, makes life so easy. Right. Why would you want to use anything else? You just add your bolt. This look more like it now. Look there. How can I tell you something wrong, you know? You're a genius, you know? You're not a genius, too. Don't worry yourself. Everyone can do it. Everybody can do it. Copy. Boom. And boom. Always use a center line. From center point to center point. It's always work with the center lines. Boom. And the bolt is on. You see that? It's just that here, we'd have to extend the hidden lines now. Come all the way out here. Because they're hidden behind the bolt. Hidden behind the bolt. Advanced level on there, no. Can't go all that again. No, sir. Some man not have the hidden line here, so remember say the pin is hiding behind this web, right? So you want to show it as hidden line. Good. And then after you do that, you know, so you're almost done. So you're basically finished. You can complete a drawing like this, put them in your sheet, label this isometric drawing, and finish it properly, because no other man give me no excuse. It's named lever bracket. So you call it lever bracket. Caps all time. Isometric view of lever bracket. And then my scale is 1 to 1. 1 to 1 is full size. Orthographic projection, date, change date to 2020. First time do this is 2019. It's 2020. It's October 8th. It's not B-made, this is something else. What class name? Fifth form. Engineering drawing. Alright. And there you have it. Everything is complete. When you do this, you drawing and finish like this, you can submit it and then you get all the grades. Because this is a whole heap of work by itself. But you know, when I get in there, from start from, can't remember when to start from. Know nothing. Don't know everything now. It's a blessing. Alright, that's it. That's it. That's it. Drawing and out and out. Alright, turn off line weight. See? Everything is good. You can call this a M18 bolt. Alright. Any measurement I use, same procedure. Same procedure. Okay. Alright, how do I turn this thing off? Here.